Okay, in this video I'm going to show you how to solve what's called a 3x3 system of equations. And what do these numbers stand for? Well, the first three stands for three variables. All right, so whenever you have an equation that has three variables like x, y, and z, and you have three equations, you have what's called a 3x3 system of equations. Okay. Now this is a really long method, so this is going to take us quite a few minutes to get through, so kind of stay with me. But basically what we're trying to do is we're trying to find where these three planes intersect. Now notice I said planes. If I had an x and a y or just two variables, I would have a straight line. But once you've added a third variable, you have what's called a plane. So you've got three planes in space basically intersecting or not, and what we're going to try to do is figure out where they intersect. It's kind of hard to visualize, but maybe we can intellectually see what I'm doing. Now the way to do that is to basically start off by choosing two of the different equations that we've got there and eliminating one of the variables. Now to help things along, I'm going to call the first equation A, the second equation B, and the third equation C. And I'm going to label each of the things I do under each one of my Roman numerals so that you understand what's happening in the set of solutions that follow, okay? So the way I'm going to start off is I'm going to look at equation A and equation B, and I'm going to eliminate the z variable. All right, so I'm just going to write all that in. Eliminate z. So let's go ahead and do that. So x plus y plus z is equal to 4, and x minus 2y minus z is equal to 1. And I'm going to use the elimination method to do that. Remember the elimination from the 2x2 systems. So I'm going to add the two equations together. That makes these go away. And I'm going to get 2x. Add these together, you're going to get minus y. Add those together, and I'm going to get 5. So now what I've done is I've basically, like I said, eliminated one of the variables, and now I have a two-variable system. I want to call this new equation D. Okay? In this method, now what I have to do is go back and pick up the equation that I did not use first. So in this case, I didn't use C. So let me write out C. And I have to pair it with one of the other two equations and eliminate the same variable that I eliminated before. Now I'm going to choose, I could choose really either B or C, but I'm going to, A or B rather, but I'm going to choose A. So I'm going to pair it with the A equation equals 4. I want to eliminate the z now. Remember, it's really important to eliminate the same variable. So choose the C equation, remember the one that I didn't choose before, and one of the other two. Doesn't really make any difference. And again, you want to eliminate the same variable. Eliminate z. Okay? Now, if I'm going to eliminate the z here, it looks like I want to multiply this second equation by 2. So let's do that. Let's move this off to the side here. That gives me 2x plus 2y plus 2z is equal to 8. Let's just bring this one over. 2x, looks like that's a minus y, sorry about that. And then minus 2z is equal to negative 1. I'm going to do the same thing in terms of elimination. I'm going to add these equations together. Those go away. And I end up with 4x plus y is equal to a positive 7. And so this new secondary equation, I'm going to call it E. Now look what I've done here. I've essentially eliminated, I've used all three equations, and I've eliminated the same variable, the z here and the z here, in the two secondary equations, the d and the e. So now what I have is a two-variable, two-equation system. So I'm going to do this again. So in my fourth step, I'm going to choose D and E and eliminate one of the two variables, either the x or the y. And in this case, I'm going to eliminate the y. So let's rewrite. The D equation is 2x minus y is equal to 5. That's the D equation. And the E equation is 4x plus y is equal to 7. Again, I'm going to choose elimination here. I could really solve this any way I wanted. I could use Cramer's rule. I could use substitution. It's just that they nicely line up in terms of elimination. So I'm just going to do these. Add these up, and you get 6x is equal to 12. And look what I've got. X is going to be equal to 2. So now, what I have done is I have found that the common intersection for all three of these equations for the x value is 2. Now you might guess what I'm going to do now, right? I'm going to start substituting x is equal to 2 back into these two equations, find another variable, and then finally take those two answers and substitute it back into the original equation and get my final answer. Okay, so let me show you how to do that. So now in step 5, I'm going to substitute x is equal to 2 into either D or E. I'm going to substitute it into D. It doesn't really make any difference. And I'm going to find y. Let's see what happens. Remember that the D equation is 2x minus y is equal to 5. I'm going to substitute 2 into there. So I get 2 times 2 minus y is 5. 4 minus y is 5. Let's subtract 4. Negative y is equal to 1, or positive y is equal to negative 1. So now I have two variables that I'm looking for, right? I've got x is equal to 2, and I've got y is equal to 1. I'm almost done with this problem now. If, let's call this step 6, or paragraph 6 really, isn't it? If x is equal to 2, y is equal to negative 1, all I need to do now is substitute into either the A, B, or the C equation, and I'm going to substitute into the A equation, and I'm going to find z. So let's try it. X plus y plus z, remember, was equal to 4. That's my A equation. Now I'm going to substitute 2 into the x, negative 1 into the y, and leaving z all by itself. So 2 plus a negative 1 plus z is 4. That gives me 1 plus z is 4, or z is equal to, subtract 1 from both sides, z is 3. Final answer, therefore, is going to be an ordered triplet. Not an ordered pair, but an ordered triplet. X is 2, y is negative 1, z is 3. So these three planes intersect at the point 2, -1, 3. And to find out whether that's true or not is you would take each one of these points, plug it into the original equations, and see if they work. And in this case, they will, I can guarantee you. Okay, I hope that was helpful. So again, what do? Let's just go through the steps one more time. Step 1, choose 2 of the equations. Doesn't make any difference. Eliminate one of the variables. Come up with a new 2-variable system. In the next step, choose the 3-variable one that you did not choose initially, pair it with one of the other 2. Again, it doesn't make any difference. Eliminate the same variable. You'll end up with two 2-variable equations. Solve it using anything you want. Just eliminate another variable. And once you get that answer, then restart substituting backwards. Take whatever that x is, put it into one of the 2-variable equations, get another variable, and then finally put both of those into the 3 variables and come up with an ordered triplet. And there's your answer. I know that was long. I hope it was helpful. Watch this video as many times as you need to get the right answer. Good luck to you.